Hello, hey, we are back. Still in the same chapter, but now on to sort of a different topic, but still sort of a geometry idea here. This topic, converting units of measurement, really it's very important if you ever have to take a chemistry class or a lot of science classes, because you're measuring things and you might want to convert units, or maybe two measurements you're given are in different units and you want to compare them. You have to convert. So first of all, I wanted to say, I know a lot of times converting is not too complicated and you can kind of just, you know exactly what to do. So for example, I'm just going to make one up here real quick. Let's see, oh wait, why is this so, there we go. Okay, like for example, if someone said, how many, let's see, inches are in, I feel like I'm phrasing this weird, but hopefully you know what I mean, are in 5 feet or something like that. You know, a lot of times we're familiar with how many inches are in a foot, that kind of stuff. So, and we don't even need to we don't even need to consult this chart, even though the conversion is up here at the top. 1 foot is 12 inches. And for more complicated problems, we might say, well, what am I supposed to do with these numbers? I'm given 5 feet. This conversion up here says that 1 foot is 12 inches. Okay, well, what do I do with that? How am I supposed to use that? But I think instinctually or just from past experience in life, you probably already know what to do. I just multiply the numbers, so that'll be easy. I'm just going to say 5 multiplied by 12 is going to be 60. So if there's 60 inches in 5 feet. Those are the same, they represent the same length or distance, I guess, but they're in different units. So I think, and I understand a lot of them you can do in your head, and that's fine if, there's an exam problem and you could just do it in your head, or you don't really know how to show your work because it's just so simple to you. That's fine. I just wanted to preface this section with that I know there's a lot of conversions you can do simply like that, but eventually if you take chemistry, there will be conversions that are complicated and you will need to do it the way that we're going to do it in this section. So at first you might say, wait, why are we doing it this way? It's kind of making it more complicated. It seems like overkill. Why would I do all that? But yeah, there are some where, especially chemistry, I feel like that's a tough subject. You talk about milliliters, and then of course there's the metric conversions. You have the metric system versus our imperial system that we use here in the US. And then, it just gets so complicated. So it's nice to have this systematic way of doing things if you don't know. But yeah, obviously there are times where you can just kind of do it in your head, or you know exactly what to do, sort of. So I hope that makes sense. I'm trying to get you to buy into what we're doing today in this section. Anyway, so first we'll talk about kind of the basic, I think they call them imperial units or UC Customary units. It depends kind of I don't know, where you're from. I guess maybe they call it different things, but these are we're not using the metric system here yet. Maybe later in this section we will, or maybe in chemistry you will, or whatever class that you might use this in. But these are a lot of units that we use in the United States. So like the one we just used, we said, okay, well, 1 foot is 12 inches. Okay, we all know that probably because that's how we measure how tall people are. It's in feet and inches type of thing. And there are 3 feet in 1 yard. So of course, inches are the smallest, or one of the smallest units in the US. And then there's feet, and then yards are bigger than that. And then even bigger than that are miles. 1 mile that's the downside. If you're familiar with the metric system, the conversions are very simple. It's like 10, 100, 1,000, 10,000. Just one followed by a bunch of different zeros are the conversion type of, the numbers in our conversions. Here it's in the US. Who comes up with this stuff? Who knows? Someone just made this up one day and we just still use it. 5,280 feet, really? Like, what's the significance of that number? Why not just 5,000? Or why not, you know what? It's kind of like, it's too late now. We're in it to win it with this conversion system here in the US. I don't know. Anyway, and then you're probably familiar with this, that there are 16 ounces in a pound. There are 2,000 pounds in a ton. I only know that from when I was a kid and I'd read books about animals and they said, oh, an elephant weighs, 2 tons. And by the way, 1 ton is 2,000 pounds. Other than that, I would never be familiar with a ton. And let's see, 1 cup, now we're talking about liquids and volume here. 1 cup, a measuring cup full is 8 fluid ounces. 1 pint is 2 cups. 1 quart is 2 pints. 1 gallon is 4 quarts. Oh my gosh. I'm only familiar with gallons because I buy, milk or juice or whatever at the store. Otherwise, I wouldn't know what the heck. And then time, of course, I think we use these so often, it's not necessary to look them up probably, right? 1 hour is 60 minutes. 1 day is 24 hours. This one's kind of not technically quite correct. It's 1 year is 365 days, but what about a leap year? Sometimes there's an extra day. But just to keep it simple, most years there are 365 days in the year. So, but just to keep it simple, yeah. So these are the conversions we'll use, but I just wanted to preface it with, I know a lot of this is not necessary, the stuff we're going to do, but in later sections or different classes you might take, it might be necessary to do it the long way that we're going to show. So let's just read the definition of what they call dimensional analysis here, and then we'll be able to kind of do some conversions. Let's see. And I think okay, I'm going to just read it. Don't get too far ahead of myself here. Okay, so the definition, dimensional analysis. It sounds like something really complicated, right? I think I remember taking a chemistry class and the professor said, you should know dimensional analysis before you come to this class. And I said, oh my gosh, what the heck is dimensional analysis? And how am I supposed to know that before I come here? But really, that's just a fancy way of saying you want to convert from one unit to another. Just a fancy name. So don't get too scared. It's nothing scary. Like I was scared. You're just conversion of units from one dimensional unit to another. Kind of like we did with, what did we use above? Yeah, we did a simple one with inches and feet, which can be used to evaluate scientific formulae, I guess, where that's the plural of formula. So that's the definition I found on Wikipedia. And Wikipedia doesn't lie, right? It's always true, even though anyone can edit it. Don't worry about that. Another definition, a unit fraction. Okay, now both of these definitions, you don't need to memorize them. I'm not going to test you like, give me the definition of this thing. It's just, that way if I say this in a video or you see the name dimensional analysis, you'll know what it means. That's the only reason you might be interested in this definition. And then the same thing with this one. If I say the word unit fraction, that way you'll know what it is. But a unit fraction is a fraction which is equal to 1, which we'll see below, because numerator and denominator are equal and whose numerator and denominator contain different units. So really what we did in this box down here that you can probably kind of see, you can see it in your own notes. I don't know if this video is big enough to see all of it, or your eyes are good enough. Mine not so much, but your younger eyes probably can. All we did was take each of the conversions, like for example, the very first one we used at the very top where we did that really simple example. I think I said how many inches are in 5 feet, something like that. I think on the top it said there's for 1 foot, that's equal to 12 inches. So all we did was take that and make a fraction out of it. So you notice that 1 foot is in the numerator here, and then 12 inches is in the denominator. On the next fraction that's next to it, we just did the opposite. Let's put the 1 foot in the denominator, and then the 12 inches in the numerator. And both of these fractions are equal to 1. This is equal to 1 because the numerator and denominator are the same. So it kind of feels weird because they're in different units. It's kind of weird to imagine that this is a 1. But it's similar to like in math, if you were to do some kind of calculation with fractions and you end up with, I'm just making this up, like 13 over 13, you can say, oh, that's equal to 1. That's all it is. So all these fractions here, these unit fractions have to have the numerator and denominator exactly the same. So it has to be true, like gallons and quarts, you have to have the same number, that the conversion rate. So for example, this guy down here, we got, where is it? What am I trying to do here? Why is this not working? There we go. 1 pound is 16 ounces. So these are equal things. 1 pound, if someone said, oh, this thing over here weighs 1 pound, and I said it weighs 16 ounces, we're saying the same thing, just in using different units. So these unit fractions have to have equal measurements in numerator and denominator. But yeah, that was another one. The second one, I think above and on the page prior, I think we had one conversion that said 1 pound equals 16 ounces. So we're just taking that equality and making a fraction out of it. And we'll see coming up in some of the examples that in some situations, one of the fractions is what we want. So for example, there might be one problem where I would like to see 1 pound in the numerator and 16 ounces in the denominator, or for some reason that we'll see soon, in one of the examples, it might be more useful to see the ounces in the numerator and the pounds in the denominator. And we'll talk about how do you know which one to use for your particular problem you're given. Yeah, so that's all we did here. All these conversions that I'm kind of boxing, they're all just taking the conversions from the first page, these guys, and just making fractions out of them. And each of them can make two fractions. You can kind of switch the numerator and denominator. So that's all these are. They look different and more complicated, but it's exactly the same as what was on the previous page. We're just making fractions out of them now. So we got time at the bottom, days to years, hours to days, minutes to hours, etc. And then here we got the volume conversions, gallons and quarts, cups and ounces, blah, 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 all that good stuff. Miles, feet, da-da-da-da. Lots of stuff. So the idea behind this what we're going to do, this dimensional analysis type of thing, is if let's say, I'm going to go over here. Let's see. I'm kind of making myself run out of room. But imagine you got, let's see, especially the volume. I'm thinking one cup is 8 ounces, 1 pint is 2 cups, 1 quart is 2 pints, da-da-da. 1 gallon is 2 quarts, that kind of thing. What if I said I have 2.5 gallons? Convert that to quarts? Yeah, quarts. So I would probably say, okay, well, I'm starting with gallons. Oh, no, let's say, I'm sorry. I want to change it to pints. Let's just be crazy. And I don't think we should really do this. Yeah. 2.5 gallons to pints, I might say, well, which conversion should I use? Well, if I'm starting with gallons, let me look for a conversion that actually has gallons in it. Let's see, where do I see gallons? Well, here's one with gallons, but you notice that it's not ending in what I want. I would like it to end in pints. We want to end in pints, but this conversion ends in quarts, so I probably have to use that conversion. I might write it down over here just because I know I'm probably going to have to use it. 1 gallon is 4 quarts. And you can abbreviate these, of course. Q for quarts. There's no other unit here in this table that has a Q, so I think we know what you mean. And G for gallon. I think that's fine also. There's no other unit that starts with a G other than gallons. Yeah, so let's see. Now, I can use that to give me quarts, but how do I get from quarts to pints? Oh, here's another conversion, so I'm going to have to use that. It's almost like, to me, I imagine it's like stepping stones. Here's me. Oh, whoops. I'm drawing with the wrong thing here. Here's me, da-da-da. Kind of like with the last section we did where we had a little person walking around to find the perimeter. I want to go across a river. This is kind of silly. But, you add art in math and it's more fun. You add art in anything, it's more fun. And I want to go across a river. Here I am, but it's like, well, I want to go to the beach on this side. Here's a beach over here. It looks pretty nice. But I can't get over there. I need to step on one stone or one rock and then another rock to get there. So that's what I need to do. Each conversion is like a rock you're standing on. I don't really want to end up on this rock here necessarily. That's just my stepping stone to get to the next spot and then to the next spot finally. So that's how I feel. Like, I know this conversion here, 1 gallon equals 4 quarts. I don't really necessarily want to end in quarts, but it's kind of like a tool I have to use to get to where I want. It's one of the stepping stones along the way. The next one might be the 1 quart equals 2 pints. And then I'll end where I want, I guess. Because I think we wanted to go to pints, right? In this problem that I made up on the spot real quick. Yeah, we wanted to end in pints. So each of those conversions might be kind of a stepping stone. Yeah, and you might, even that one, you might already know what to do. I know I need to multiply or I need to divide or whatever to get to where I want to go. But there might be more complicated, ones of these, especially in chemistry, where you can't do it that quickly. So I just wanted to point that out, that there will be conversions where we have to use more than one, conversion rate or more than one unit fraction. So anyway, so we're gonna get down to how do you do this with those unit fractions? What do those have to do with anything? Why do I need to involve fractions? I hate fractions. No, most people say that. In order to convert from one unit to another, we must use the above unit fractions, the ones that were in the second box where we just took the conversions and made them fractions. The process includes, first, thinking of the given quantity as a fraction with denominator 1. Then, so that's like the one, there it is, there's that example. I'm not very creative. Here it is right here. Let's try to do this. I know it sounds silly. Let's do this the hard way instead of doing it the easy way. No, just to get used to the idea of this kind of complicated process, we'll do a simple problem the hard way. That way, when there are actually hard problems, we'll be ready to do it the hard way, if that makes any sense at all, hopefully. Let's say we're trying to convert 5 feet into inches. You might already know how to do that. You know exactly what to do, but we'll just do it the long way. So as it says, okay, we already kind of talked about this. I'm going to think of the given quantity as a fraction with denominator of 1. So in this problem here, what did they give me? I'm given 5 feet. So I'm going to make that. It was just 5 feet on its own. I think if you remember in one of the previous math classes you've taken, probably, you can take any whole number, like this, in this case 5, and make it into a fraction by giving it a denominator of 1. So that's what I'll do, because what I want to do is have this fraction, this 5 feet interact with some fractions, those unit fractions. But I can't really multiply fractions by a whole number. They have to both be fractions, but you can easily make a whole number into a fraction by giving it a denominator of 1. So that's the first thing we'll do. First step, just put a 1 underneath it, give it a fraction bar, put a 1 underneath, bada bing, bada boom. Step 1's already done. So think of the given quantity as a fraction with denominator of 1. Then we're going to multiply by 1 or more unit fractions, being sure to have like units. This is kind of the complicated part. Be sure to have like units line up along the diagonal. So it's kind of what you're wanting to do is you want, like it just said, you want to see like units along the diagonal. So for example, here I have feet and here I have, foot. Feet, foot, it's the same unit, just plural or singular, right? So, and the reasoning behind that is in this problem, I'm starting with feet, of course. They gave me 5 feet, but I want to end in inches. So it's like me standing on one rock. This is the feet rock. I don't know. And I'm trying to get across. I don't want to stay here. I want to go over here to the inches rock or the beach or something. And there's water along the way. What do I need to use? I'm going to use this conversion that there are 12 inches and 1 foot to get there. But along the way, I don't want feet to be in my answer. I just want inches to be in my answer. And of course, with fractions, the way to get rid of something or the way to cancel something is to see it along the diagonal. So you see this little blue line, they're being crossed out. Foot and feet cancel. But I would say liken it to fractions, like back when you had no context behind it. You know, if you had, let's say, 2 over 3 multiplied by, I'm just making this up. This isn't part of this problem. I'm just reminding about reducing and stuff like that. If I had 2/3 times 1/4 or something, I could just multiply across, but it's probably quicker and easier to simplify it first. The way that you can reduce is either vertically. So for example, if this 2 and the 3 had a common divisor, I could reduce that, but they don't. But also diagonally, I could reduce this way or this way. The second diagonal arrow I just drew, there's no common divisor between 1 and 3, but the 2 and the 4 have a common divisor. If I divide 2 by 2, I get 1. If I divide 4 by 2, I get 2. And then I can go multiply across. That would be 1 times 1 over 3 times 2, like that. So that's kind of what we're trying to do. I know I can reduce along the diagonal with numbers. Same thing with units. If I see feet across from each other, diagonal from each other, they can cancel. And then if you look at what's left in this box I'm drawing, the only units left after those feet and foot cancel is inches. And that's what I want. I want to end in inches. So that's how you know you've done exactly what you should. But notice if I were to do it the other way, I'm just gonna write this real quick and then erase it. I'm starting with 5 feet. So as they said, the first step is just imagine that whole number that you're given and put it over 1. Now imagine I knew how to convert it. So I knew that I have to use this conversion. The 12 inches is 1 foot. But what if I use the opposite unit conversion or fractional conversion? Instead of 12 inches over 1 foot, what if I didn't really know what I was doing and I said, well, 1 foot is 12 inches and I put it upside down? I would know that's wrong right away because I know what I want in the end is inches. I'm starting with feet and I want some number of inches. But notice that the feet, here's the feet in the numerator and here's feet in the numerator also. They cannot cancel. So in this case, I would be left with feet in my units and I'd be left with inches. I don't want that. So I know that this guy's upside down. He needs to flip upside down. It should be the other way as it's shown in the original problem up here. I don't want it that way. So that's what you really need to look for is, and that's how you know which of the unit fractions you need to use. Because as we saw in that box above, let's see. Sorry, I may be over-explaining this, huh? I don't know. But like in the one, which one's the one we're using right now? Yeah, between these two, we got You got 1 foot is 12 inches, 12 inches is 1 foot. I mean, those are both the same conversion, but there are two options. You can change the numerator and denominator, but that's how you know which one to use. Like if there's another problem maybe in the future where I'm given something and I want to convert between pints and cups, I've just got to, which one do I use? Do I use 1 pint over 2 cups or 2 cups over 1 pint? Well, which units are going to cancel along the diagonal? If I'm starting with pints, like if I was given, I don't know, 5 pints, and I want to convert to cups, which one of these fractions do I use? I want to make sure that pints are in the denominator here so they'll cancel. So which one of these would that be? This second one, I would want 2 cups over 1 pint, that kind of thing. That's how you know which one to use. Just think, what unit am I starting with? I want those to cancel along the diagonal. Make sure that happens. That's kind of the idea. So sorry, I'm kind of all over the place here, but yeah, that's the idea. And then multiply and divide as needed. Just if there happen to be in the numerator some numbers, I know it's kind of hard to even imagine or see what the heck I'm doing here. I've written too much. Here, it used to look like this without all the crazy writing and colors and stuff. But yeah, whatever's left, once you realize, yes, my units are going to cancel correctly, what do I have? I have 5 in the numerator multiplied by 12. Okay, so we got that over here. And then in the denominator, there's just 1 times 1, so that's why that's left in the denominator. And I guess you could technically say it's 60, because 5 times 12 is 60 over 1. But that, like we said earlier, any fraction whose denominator is 1 is just a whole number, so you might as well, since we're all done. And I know that seems like the long way, but yeah, there are problems where you will have to do it the long way. You can't maybe necessarily do it in your head, especially if you take, I know I said the word chemistry too many times in this video, but if you take a chemistry class, some of the problems are so complicated, there's no way I could just know, oh, I multiply this or I divide that. I would have to do this fraction thing or I wouldn't know what the heck I'm doing. So it seems complicated, but the more examples we see, the easier it'll get. And then it'll be like, oh, actually, this isn't that bad. And in this class, since there's no math prerequisite, and it's probably a class you're taking where you don't really need a lot of more math, we won't get too complicated with these examples, but especially if you know you're trying to do some kind of science or take another science class, you might want to do it the long way, even though, yeah, it might be painful. So anyway, let's try these examples and see how it goes. Let's see. Example 1 says, Izzy's GPS tells her that her trip from San Diego to Long Beach will be... Oh, wow, I don't know. So first of all, sometimes you got to suspend your disbelief. It's like, really? Why would the GPS tell me my trip distance in feet? That's ridiculous. Oh, well, just suspend your disbelief. Pretend like this is something that happens. Here we go. We got this many feet to go from Long Beach to San Diego. That's funny. 1,060,720 feet. Wow. How many miles will she drive? Okay. So this is me. I'm starting on almost, I know it sounds silly, but for some reason this makes it make sense to me. I'm a little person here, and I'm starting on at this spot. I have no body, I guess. My hands and my legs are starting from the same point. Don't worry about it. And I want to go to where? Miles? Yeah. So I don't know how many rocks I need along the way. There might be 1 unit conversion to get from one to the next, or I might just be able to use 1 unit conversion to get right to where I want to go. So I'm going to go back to the table of... conversions and then see which one I need. I'm going to look for one. I hope there's one with feet and miles in it. If there's not, I might have to do 2, where maybe feet is converted to some other intermediate unit, and then that intermediate unit can convert to miles. I cross my fingers that there's one with miles and feet, but, we'll see. I could get lucky. And I want you to know that you don't need to memorize the conversions. Don't memorize them. If you don't, you can if you want. The conversion table on page 1 of these notes will be given on any exam or final or whatever, or final. But I guess what I want to point out is that would be the first table. So let me see. I hope this doesn't hurt your eyes or make you dizzy when I move the screen like this. But this conversion table or any other conversion tables would be given to you as needed. But it's your job to know how to make them into these unit fractions. So these will not be given, but like I said, they are just these exactly, but you make an equality into a fraction, that's all. So just know you don't have to memorize them, just know how to use them. Yeah, while I'm here, what was I looking for? Man, don't get old, you guys. That's when you start just forgetting. You walk into a room and say, wait, why was I here again? Here's the conversion I want. Because I think we started with feet, right? And we're going to miles. Okay, there are 5,280 feet in 1 mile. Okay, got to remember that. You might already know that. That's cool. But, if you don't know it, don't worry. It'll be there. So I think I'm going to move all this stuff. I drew, why would I draw a picture of a person jumping on rocks? You probably have the weirdest teacher you've ever, in the whole world. Whatever, you know what? It makes it more fun. So, what did we start with again? 1,060,000, was it 720, I think? And what is that feet? Let me just scroll over, make sure that's actually right. Oh my gosh, I can't believe I actually remembered that. But now we know that there's 1 mile is 5,280 feet. Okay. So I got to think about, that's the conversion I want, because I think they said we want to end in miles. Okay, so that's good. There should only be one conversion. Now the question is, am I going to write this as a fraction with feet in the numerator and miles in the denominator, or miles in the numerator and feet, Which way am I going to do it? Well, I want feet to disappear, because I don't want my answer to be in feet. I want to be in miles. You know what? And I should have put feet up here, because this down here, it kind of looks like it's in the denominator. But it's in the numerator, I promise. And then, like I said, we're supposed to put this over 1. If I want my feet to cancel, I better see feet in the denominator. So that means which of these quantities from my conversion that I realize I needs to go in the denominator, the one with feet in it. 5,280. That must mean, I guess, miles. 1 mile goes on the top. 1 mile. And again, you might have already known as soon as you read this, well, I just divide the number given by the number of feet in a mile. That's easy. But yeah, it's good. Like I said, it's good to get in the habit of doing it this long way, just because in the future, maybe in this class or future classes, you might need to do it the long way, because sometimes it's not obvious. There might be a problem where you're multiplying and dividing by stuff and it's not really clear what to do. This will always serve you well. It might seem like overkill, but it'll always work. Anyway, I'm going to do that on I got to multiply across, I guess. So across the 1,060,720 multiplied by 1 is just that number, 1,060,720. And then over, 1 multiplied by 5,280, that's just 5,280. And then this is where you can check real quick. Even if you think you did the right conversion, let me see, did all the units I started with actually cancel each other? Yes, feet along the diagonal are gone. What units left? Miles. So I'm going to check. Is that what I really wanted? Yes, good. That must mean I did the right conversion, or I guess I used the right conversion and I put the fraction the right way. Now I just need to divide those. Okay, that's not so bad. So that's what it comes down to. Just divide 1,600,000 by 5,000. Okay, sorry if the explanation for this seemed very long-winded. I'm sorry. I just remember being a student. Maybe you weren't this way, or you're not this way, but this stuff confused me very much. And I took it in chemistry, and it was not easy to me. 5,280. Okay, I'm getting about 200, and they didn't tell us where to round. I would think on the test they would tell you where to round, but it's somewhere around this thing, 200.89, or you could probably just say that's about 201 miles. Either way, I mean, if they didn't tell us where to round, they got to be happy with whatever we give them, All right, but of course a GPS would probably say 201 miles. They wouldn't say 1 million something feet. That's ridiculous. But I just, a weird scenario. So hopefully that makes sense. There's our answer. And yeah, you might have already known exactly what to do with the numbers, the conversion of 5,280 feet in a mile, and then the number given. But it's good to practice this, I promise. Yeah, where was that? I feel like that reminds me when I was a kid. I'm old, so we had a computer class, and it was just to practice typing, your words on a computer. And they told me, make sure you rest your fingers on, A, S, D, F keys, and your other fingers on J, K, L, whatever. And then I was like, nah, I'm not going to do that. I thought it was a waste. I don't want to rest my fingers. I'm just going to type. And of course, we were typing small words. And then I never really got good at the resting your fingers thing, and I should have just listened to them. So it's kind of like this. If you don't want to listen to me to do it the long way, you say, nah, I don't need to do that. That makes it more complicated. But eventually, someday, there might be a time where you'll say, dang it, I should have actually listened and done it the long way, because now I don't know how to do it the quick way in my head. Anyway, I'm trying to convince you. I don't know if it's working. Example 2. In 2025, $1 is equal to 19.64, that's very specific, Mexican pesos. When visiting family in Mexico, Nolan paid 45, let me get this out of the way. Okay, 45 what? Pesos for a cup of coffee. Okay. It's like, is that expensive? Is that a good price? Well, we're going to find out. How much would it cost in US dollars? Okay, that's a good one. So there might be some examples like this you might come across in the homework or on the exam. They would have to give you the conversion unit rate, because that's maybe not one of the typical conversions you would see in a table of values, like in a chemistry textbook or a math textbook. And that's mostly because this number changes all the time. You know, the conversion rates from one unit to another, dollars, and that kind of stuff. So it should be given. You need to use that. Now I need to set this problem up here. What do I got? What am I starting with? So this is the conversion rate. This is not the number I'm starting with. They're just saying this is how many. So I'm just really what's going to happen with that is I'm either going to use the fraction 1. I guess I could just put dollar, huh? I was going to write the words US dollar. Why would I make my life harder? And 19.64 pesos, or the other way around. It could be, it depends, kind of what I need to do. I'm not sure yet. It could be upside down. You never know. Let's see. We'll see. One of those I need to use. Okay. They must be giving me a number to start with. Oh yeah, he paid 45 pesos for a cup of coffee. So we're starting with that, I think. Sometimes there's so many numbers given in a problem, you don't know where to start. But this is where we're starting, 45 pesos. Okay, now that's the number we're given. I think the step 1 of this process, as we outlined it above, was put that number over 1. And now think about what you need to do. Well, I know I want to get rid of pesos and I want to write dollars. So I want to make sure that the unit I'm starting with cancels. So whatever happens, I want to make sure that pesos are in the denominator. I guess what I want is dollars. So I'm going to hope for that. Which one of these unit fractions gives me that? This first one. That must be the one I want. I'm going to bring him over. So I guess this one, maybe in a different situation, that fraction I just X'd out would be useful, probably if you're starting with dollars and you're trying to go to pesos. But I'm going the opposite way, so I don't need that today. Maybe next time, thank you. $1, that's right. And was it 19.64? Okay. Those are all running together. That's a number and a word. I think that looks good. Okay, and then you're going to check real quick. Yes, are the right units canceling? Yes, okay, I think it looks good. I want to end with dollars, and that's what I'm ending with. That's the only unit left. Now I'm going to multiply across. We got 45 multiplied by 1. The numerator gives me 45. That's easy peasy. And the denominator, what is it? 1 multiplied by 19.64. So that's division. As you've probably seen in previous math classes, any fraction can be thought of as division. That's $45. It's kind of like dollars is the end result. I'm doing 45 divided by 19.64. Whatever I get is the number of dollars. So let's see. What would I get? That's 45 divided by 19.64. I got about 2.29 or so. So that's dollars. And then at this point, usually I forgot why was I doing that again? What did that represent? Oh yeah, that's the cost of a cup of coffee. That's pretty good actually, I think. That's not bad. If someone said, here, I'll give you a cup of coffee for $2.29, that's a pretty good deal actually. Good job, Nolan. You got a good deal. Anyway, interesting. Okay. I like coffee. How about we'll try the next one? Hopefully this is making sense. It's definitely the more you do, the better you get. So example 3, how many inches are in 3 miles? Okay, I guess we're starting with 3 miles. All right, and I want definitely whatever conversion or whatever, I always forget the name, unit fraction for some reason. I want to see something with miles on the bottom because I want to make sure they cancel after I put this over 1. And I want to get closer to inches. That's where I want to end up. So I really don't know at this point how many. I might need one only unit fraction. I might need more than one. But in the end, I want to make sure I land on inches, whatever it is. I don't want to land on feet or yards or whatever. I want to make sure my answer is in inches. And again, this is kind of, for some reason, that makes it make more sense to me. I'm here. I'm starting with miles. Here's me on this rock. That's where I'm starting. But I want to end on inches. And I got it kind of along the way as I step from rock to rock. It's kind of as I go, I'll determine how many stepping stones do I need to get there. I might be able to jump right there if there is a conversion between miles and inches in that table. If not, I might have to step on an intermediate stone or another intermediate stone to get there and then move to the last one. It kind of depends what the conversions look like. But I want to, first of all, for sure, I want to look for one in miles. That's my first step. Look for miles for a conversion with miles in it. And I know I want inches in the end, but for my first order of business is to get rid of the miles. Maybe I'm not going right to inches, but I for sure need to get rid of miles first, and then I can worry about, well, how am I going to get to inches eventually? So it's kind of like in this analogy here, I need to make sure I step off the miles rock to move forward towards where I want to go. I want to eventually get to this inches rock. That doesn't make any sense. But you know what I mean. It's an analogy, I guess. But I got the first thing, before I get to this rock over here, I need to step off the first rock. So I want to make sure I get rid of miles first. Okay, let me see. I hope I don't have to use too many fractions. But what are you going to do? Which one had miles? I'm not... Oh, we just used it, didn't we? Oh my gosh. 1 mile is 5,280 feet. I think that's the only conversion here, at least in this table, that has miles or has a mile in it at all. And I know that feet is not what I want to end up with, but you know what? I think that means there's just an intermediate stone we have to step on to get to where we want to go. 1 mile is 5,280 feet. All right. And maybe I don't see the whole problem in my head. I don't see all the steps outlined. I'm just doing one thing at a time. Kind of like, imagine you're crossing a river or something. You don't necessarily see across. I know exactly how many stones I have to step on to get across. You just kind of do one thing and see how it goes, and then maybe see what you have to do after that. That's what I'm doing right now. I really don't know how many steps I need to take to get there, and I don't know my next step, as long as I know how to get from this step to that step. But okay, there was a conversion that said 1 mile is 5,280 feet. So I guess that apparently I'm going to go jump to a stone that has feet, and then maybe I want to end up with inches. Like I said, at this point I might check, am I done? Can I stop now? If what they asked for was inches, if they asked for feet, then I could stop. But they wanted inches. Right now I'd be ending in feet. That's not what I want. So I need another fraction. This might be the first time we've seen this. I've definitely won. And then again, the miles are gone now. Now that I've multiplied by this 5,280 feet, miles are over. I'm now in feet land, but I want to get rid of those. So I need to, again, make sure that feet are in the denominator to cancel out. This will cancel with this. And I want a conversion with feet in it, and hopefully inches also, if there is one. If there's not, that might be another stepping stone. But I believe there's one, right? There's 12 inches in 1 foot. So I could go back and look at that table, but that's for sure one conversion I memorized in my life. There's 1 foot in 12 inches. So I think we're done. This is a complicated one because, you started with miles. Your first order of business was to find a conversion that cancels the miles. But then I look and say, well, what unit am I ending in here if I stop at this fraction here? Oh, I'm ending in feet, but that's not what I want. So that's like me stepping on another stone to get where I want. The feet will cancel now that I've used a unit fraction that has feet in the denominator. The only unit left after all the canceling is inches. That's exactly what I want. So I know I'm done with my math. Now I just multiply across numerator. And feel free to, for sure, you can kind of show it in steps. Maybe you don't have to do this. If you just want to write very little on your paper, that's fine. Don't worry about it. But just to really show the work, that way if you get stuck, you can kind of see what we did. I'm going to erase all this. Oh, maybe I should leave the answer just in case. I don't know. That's all done. Okay, so now I'm going to multiply the numerator together. You could just multiply it, but I'm just going to write it so it's maybe more clear what we did. There's a 3 in the first numerator, 5,280 in the second one, and the third numerator had a 12. I'll multiply all those together eventually. But all these denominators, 1 times 1 times 1, that just makes 1. Okay, that's easy peasy. So what would that be? Okay, what is it? 5,280 multiplied by 3 multiplied by 12. I believe, as long as I typed it in my calculator correctly, 190,080. And I was ending in inches, right? Yeah, inches. That's a lot of inches. But it's in miles, so that makes sense. Whew. That was a lot of work. And maybe in that one you might have even known, well, I know I need to take the given number and multiply it by this and multiply it by this. But yeah, like I said, there might be a point in your life or a class you take where you won't know what to do with the numbers and you have to do it this way. Yeah. It's kind of like in the weird analogy that I had with the person walking or trying to cross a river. You might know, like, if it's a really small river and it's not very wide, I might be able to see the steps along the way that I need to step on, but there might be eventually a river that's wide enough that I can't see as many steps or how many rocks I need to step on. So that there might be a time eventually. Anyway, next example. Hopefully this is making sense and it's not too bad, and I like the practical application. I appreciate that in math. Sometimes math is so weird and theoretical. It's like, what the heck? Who's going to use this in real life? But I could kind of see this, kind of. Yeah, I like that. Anyway, what do we got here? Example 4. It says, at a family brunch, a large carafe, I didn't know that word. I saw it in a movie or something, so I threw it in there to make me feel smart. A large carafe of juice, which is just like the pitcher you pour it out of, on the table contains 2.5 gallons of juice. If each glass can hold about 1 cup of juice, how many cups of juice can be poured for guests? Ooh, that's a good one. Okay, this is kind of an overwhelming one. It's like, oh, there's so many numbers going on and Let's see. If each glass can hold 1 cup. Okay. So it sounds like what we're starting with, this carafe or pitcher or whatever, it's got 2.5 gallons. And I don't know really what to do, but eventually I want to go to cups because I said each glass can hold 1 cup of juice. So I guess what we're trying to say, it's kind of a complicated way of saying how many cups are in that many gallons. In other words, how many cups are in 2.5 gallons? Yeah, that's what they're trying to say. So I want to go from gallons to cups is what the simplest way to do it. That's the simplest thing we're trying to do. How do we get there? That's a good question. I'm going to start with 2.5. And then I know this whole process, dimensional analysis, involves fractions. I don't really like seeing fractions within fractions. So for me, I'm going to change it to 2.5 because that just seems easier. Eventually, I'm going to be putting things in my calculator. It's much easier to put 2.5 in my calculator rather than 2.5. So that's probably the first thing I would do. If you're given a fraction as part of the number you're given, I would just immediately change it to a decimal. All right. So what I want, like they said, the first step would be put that number over 1. And I definitely want to make sure as I step off my first stone that I'm standing on to get to the other side of the river, I want to make sure I see the same unit in the denominator so they cancel. And I would love to go back to the unit conversions and see cups and gallons in the same conversion. That means I only need to step on 1 stone or only use 1 unit fraction to get there, but we'll see how it goes. What do we got? Where's the gallons? I probably already saw it not that long ago, but my memory's so bad. Okay, which ones of these have gallons in them? I'm looking, I only see this one, I think he's the only one with gallons, so we're pretty much going to have to use that one. If I want to get rid of gallons, I have to use a conversion that has gallons in it. Even though the other unit is quarts, that's not really what I wanted, but that's okay. We'll get there. 1 gallon is 4 quarts, okay. I don't really know necessarily at this point how to get from the quarts to the cups, but that's okay. We'll get it, don't worry. We'll assess the situation after we're done writing this. What did we say? 4 quarts? Quarts and 1. I know that's not correct. Gallons. 1 gallon, gallons, whatever. So we're getting there. Okay. That's not where I want to end, so I must need another stepping stone or another fraction to get there. Okay, and definitely I want to see the same units, the quarts. I want to get rid of quarts because quarts was a tool to get to where I want to go. I don't want to end in quarts. I want to end in cups. So I better see quarts on my next conversion, or what do you call it? Unit conversion or unit fraction in the denominator. And I hope there's a quarts and cups one. Let me go back. If not, you know what? That's another stone. This must be a wider river than I thought. That's okay. We'll cross it. Quarts. All right. Where do I see quarts? Sorry if this is hurting your eyes. Quarts. I think the only place I see quarts is this yellow one, 2 pints. And I know pints aren't really where I wanted to go, but I'll probably use these. I probably have to use these too, because right now, this is pretty much it, huh? Right here, I'm going from gallons, let me see, gallons to quarts, and then quarts to pints, and then pints to cups. There's a lot of stones here I'm stepping on from, I think that's what we're kind of doing. We're starting here. Here's me, I'm on gallons. I'm starting here. I'd have to step onto the stone with quarts on it. And then step onto a stone with pints, apparently. And then lastly, I can stop at cups, where I want to be. I don't really want to go here. I don't want to go here, but I need to use those to get to where I want to go. All right, so 2 pints in a quart and 2 cups in a pint. I'll remember that. All right, where were we? So much fun we had along the way here. There we go. Now, what did we say? 1 quart is 2 pints. I don't want to end in pints, but that was the only unit conversion that had quarts, other than the quarts and gallons, but I'm done with that one. But that looks like a good setup. Now I'm thinking, okay, this is where I could assess, am I done with this problem? Well, what unit would I end in? That's kind of where I would want to go. I see gallons are going to cancel, so there will be no gallons in my answer. That's good. The quarts will cancel, which means there's no quarts in my answer, which is good. But if I stop now, pints will be, my answer will be in pints. I don't want that. I want cups. So I need one more little unit conversion. And again, if I don't want to see pints in my answer, I better make sure it's a fraction that has the same unit, pint. Oh, what the heck? Sorry. Oh my gosh. I don't know how I did that. Sorry, let me start that over. 2.5 gallons. And then what we do, it was 1 quart, 4 gallons. And then it was 1 gallon is 2 pints. Sorry, now we got pints. I want the same unit in the denominator. 1 pint is 2 cups. Finally, that's going to do it for us. Because then this is where I check real quick. Are all the units that I want to cancel canceling? Gallon. Oh my gosh, this should be gallons. Sorry, that really threw me off here. Quarts. Okay, gallons cancel. Quarts cancel. Dang it, that should be quarts. What was I doing? Pints cancel. Then we're just left with cups. Okay, the units match. Now I just have to do the math. In the numerator, there's a lot of numbers going on. I had a 2.5 in this first numerator and then a 4. And you could just multiply them all together at once, but I just kind of want to show the work in case someone says, what the heck, where'd all the numbers come from? And another 2, oh my gosh. And then the denominators are all 1. It's 1 times 1 times 1. That's easy, 1. And it should be in cups. So it all comes down to what do all those numbers in the numerator multiply out to? I think 40. Okay, so I think that's 40 cups. And I guess technically it's 40 over 1, but, anything over 1 is just that number. Interesting. Okay, that's a lot of cups. So anyway, they can drink a lot of juice at that brunch. Wow. All right, that was fun. And then look at this next page. This scares me. But okay, calm down. This just means, depending on the problem we're given, we might need to use any of these unit conversions. I'll try to narrow it down on the actual exam. This is a lot of stuff. Let's just kind of look at it, though, to familiarize ourselves with it so it's not so scary. Mass and weight. So they say, what do they say? Weight and mass. What is the difference between them? Weight depends on, depends on gravity, I think I heard, and that blew my mind. On gravity. Because when you weigh yourself on a scale, you weigh whatever it is, and then if you were on a different planet that has different gravity or on the moon, you would weigh something different. Mass is similar, except you're always the same mass no matter what. It does not depending on gravity, which is kind of cool anyway. I don't know. That's how you know you're nerdy, though, if you think that's interesting. Definitely. So, kilograms, we got the first conversion here from kilograms to pounds. 1 kilogram is 1,000 grams. So those are both metric units, gram and kilogram. So notice how beautiful the number is, 1,000. So simple. I can multiply and divide by 1,000 easily because all that does is move the decimal point of a number over, right? Like if you said, well, what's 5.6, times 1,000. I don't really have to do anything on my calculator. I'm just going to take that decimal point in the 5.6 and move it 3 times because this number here has 3 zeros. So that's all it is. That's why metric system is so much easier to use than the US units. It was 5.6, but I'm moving the decimal 3 times over. 1, 2, 3, and then where there are empty spots, I put a 0. So it's 5,600, and then dividing is similar. If I had 5.6 divided by 1,000, I'm just imagining if there was a problem where I was converting from kilograms to grams or vice versa, I'd be either multiplying or dividing by 1,000. But all I do is take that 5.6 and move its decimal 3 times to the left. 1, 2, 3, so it'd be 0.0056. Yeah, wait, right? 1, 2, yeah. Why does that seem wrong? 1, 2, 3. Yeah, 1, 2. Okay. Anyway, so that's why metric system makes way more sense. Blah, 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 blah. Where are we? But if you want to convert those to pounds, which is weight, it'd be 2.205. 1 kilogram or 1,000 grams, either way, is equal to 2.205 pounds. 1 gram is equal to 1,000 milligrams. 1 pound is equal. Yeah, this is how you know this is not metric. It's a random number. Not random, but you know what I mean. It's a weird decimal number, not like 1,000 or 100 or 1 followed by a bunch of zeros. 1 pound is 453.59 grams, etc. A lot of these we won't use. I think I might even skip over the next ones. Those are probably chemistry ones. I'm not even going to highlight those because those are just for very complicated problems we won't see in this class. Maybe even I'll cancel or kind of get rid of them. Excuse me, sir. We don't need that. 1 ton is 2,000 pounds. We saw that already, huh? 16 ounces is 1 pound. Okay, those are not so bad. Length, we got 1 inch. So now we're kind of converting between US units and metric units. 1 inch is 2.54 centimeters. 1 meter, which is still, meter to centimeter is still in metric units. It's 100 centimeters. That's equal to 39.7 inches or so. 1 yard is 0.9144 meters. 1 mile is 1 etc. Yeah, I think these next ones, I don't think we're going to need these guys. I'm going to get rid of that guy and that guy. Yeah, but maybe kilometer, I could see kilometer to meters or kilometer to miles. That's pretty common. All right, and then volume, 1 liter is 0.001 cubic meter. Okay, and we saw cubic units in the last section, right? That means it's a 3-dimensional object. Or 1 liter could be 1,000 cubic centimeters, which is 1,000 milliliters. 1 liter, liters must be important. They're all over the place here. Is 1.056 quarts. 1 quart is 0.9. So we're converting between metric units and US units here. 1 quart is 0.94631 liters, etc. Okay, so there's a lot of these. I don't want to bore you with all of them. A lot of these are the same ones we've seen. If it's US units to US units, we've seen that already. All right, but anyway. But now this last table looks at how to convert from metric, just 1 metric unit to another. So it's every basic unit, I guess, for example, grams or meters. Those are kind of your basic metric units. Grams. I'm going to think about if there's, maybe make a list if we come across some grams, meters, or maybe there's more. I can't think of. They're your basic metric units. Okay, there they are. Let's see. So it's kind of, this table is kind of confusing at first, but imagining this is where your basic units are starting. Gram or meter, whatever it is, gram, meter. But if you want to add a, what do you call it? Dang, I can't remember the English word for it. But you know when you put this, a new beginning on the word, what the heck? Mega grams or mega meters, you don't hear that very often. Kilo meters, kilograms. You know, if you want to take those and convert them to, why do I do the kilograms? Or, for example, kilometers, kilometers, but you know, whatever. Then all you would do is multiply by this number, 10 to the third power, which is 1 followed by 3 zeros, and this is, this 6 zeros, 1 followed by 6 zeros, 1 followed by 2 zeros, this is 1 followed by 1 zero, or 10 in other words. And then this is where you could think of it as multiplying by 10 to the negative 1 power, or it's another way of thinking of it as dividing by 10. This would be dividing by 1 followed by 2 zeros. So these are, you would take the basic unit and multiply them by these numbers. The ones below this red line, you're dividing by 1 followed by this many zeros. 1, 2, 3, 6 zeros. 3, 4, 5, 6. And then, this one, I don't think we'll see this very often. Nano units are tiny. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's basically how to read it. So converting from 1 metric unit to another is very easy. You just got to know what number am I multiplying or dividing by. It's always 1 followed by some number of zeros. So people that use metric units in their, oh my gosh, why did I go up here? In their country, So much easier. They probably memorize all these, the conversions. That's all they have to do. I don't have to memorize there are 12 inches and 1 foot and all that crud. It's all, anyway. All right, so grams to kilograms. That's one we were talking about. 12.6 grams. 12.6 grams to kilograms. All right, well, let me look back at what we got so many units now. For sure, whatever I do, I want to make sure I get grams to go away. So I want to make sure I have a conversion that goes from grams to maybe kilograms if I'm lucky, maybe not, but I definitely want grams to be in the denominator. But grams and kilograms, they're both metric units. These both metric. So we should just have to use that last table because that's where we got, anyway. So it's basically what it says was if I want to go to kilogram, kilometer, kilometer, this is all I need to do is take the given unit and multiply by 1,000. And I knew which line of this table to look at or which row because this is where, this is the one that had kilo. I'm trying to get to kilo, this is what I do, multiply by 1,000. If I was trying to get to, for example, millimeters or milligrams, I would divide by 1,000. Just look for which prefix, dang it, that's the word I was looking for earlier. Prefix, mega, kilo, hecto, deca, deci, centi, all that. Which prefix am I looking for? And then this part over here tells you what math to do. Am I multiplying or dividing, and by which unit or which level of 10? Is it 10, 100, 1,000? Okay, so I multiplied by 1,000. That's what that table says. And that gives me kilograms. That's it. And I think these, when you're converting from metric to metric, you might not need these. This whole unit fraction idea. It's pretty simple, but it's good practice for the problems where we're not able to do that. So what I'm doing is I'm multiplying 12.6 by 1,000, and I'm supposed to get kilograms. In the denominator, I forgot, 1 gram and 1,000 kilograms. The denominator is just 1 times 1, so that's it. 1 times 1, and we're going to end in kilograms. And multiplying by 1,000, all it does is take that decimal that was between the 2 and the 6 and move it. How many zeros did I have? There are 3 zeros. So I'm going to move the decimal 3 times. 1, 2, 3. That means I would have to add 2 zeros to that number. There are 12,600. Wait a second. There's no, wait. That can't be right. Has to be dividing. I'm sorry. Dang it. I think I mixed these up. I'm going crazy. Divide. These are all divide by. Sorry, I mixed them up. These should be divide. These should be multiply. That makes sense because the top units like kilograms, kilometers, those are big measurements. So if I go from grams, which are smaller measurements, to kilograms, I should be getting a smaller number, not a bigger number. But if I was trying to go to like milligrams or millimeters, there's going to be a lot of millimeters in 1 gram. So yeah, sorry. Dang it. I messed up. I should be dividing by, I'm sorry about that. Dang it. See? Why can't our country just use metric? Then we would all be, anyway. I'll think about that later. So I just take 12.6 grams and I divide it by 1,000 to get there. 1,000 grams. Yeah, because there are 1,000 grams in 1 kilogram. So of course I'm dividing. Oh my gosh. I'm losing it, you guys. I'm sorry. 1 kilogram. There we go. That makes more sense. Ay. Losing my freaking mind. Over here, okay, 12.6 kilograms, and I'm dividing by 1,000, okay. But that's not too bad, I just moved the decimal over the other way, come on now. 1, 2, 3, because there were 3 zeros in 1,000. So there are 0.0126 kilograms in a gram, which makes sense. Yeah, grams are small, so if I have 12 grams, that's gonna be very little kilograms, because kilograms are big measurements. I'm sorry. Losing it. All right. What do we got? Now we're going to do a similar one. But I think now we're going to a smaller unit. I'm starting with 1,827 meters. And I want a conversion that will take me from meters to millimeters. All right. And those are both metric units. So I shouldn't need any of the other tables. Both Metric. Okay. Looks good. Where are we now? Millimeters. There. Okay, so I'm going to highlight it. What's a color we haven't used in a while? Sure. Millimeters. Here we go. That's the one that has milla in it. So I'm going to multiply by 1,000 because there are 1,000 millimeters in 1 meter. 1,000 millimeters is 1 meter. Yeah, because 1 millimeter is tiny. There have to be 1,000 of them to make 1 little meter. And which way should I put it? I want meters in the denominator, like we said, so that they cancel. This is the meter part. I'm going to put 1 meter, and then the 1,000 millimeters will go on top. So now it looks like we're multiplying. I mistakenly thought we were multiplying in the last one, but I guess we're not. Multiplied by 1,000, and we're going to end in millimeters over this. I forgot. I was supposed to put over 1. Multiply across 1 times 1. Okay, and if I multiply 1,827 by 1,000, it just takes the decimal that was after the 7 and moves it 3 times to the right. 1, 2, 3, which would have me adding 3 zeros. It'd be 1,827,000 millimeters, which, you know, that's kind of the nice thing is you kind of have a feel if you've heard these prefixes before, millimeter, kilometer, those kind of things. I know millimeters are tiny, so it would take a lot of millimeters to make 1 meter, or to make 1,000 meters in this case. So that kind of makes sense. But if I had some decimal number, if it was 0.0 millimeters, that kind of wouldn't logically make sense because millimeters are larger measurements. Or sorry, dang it, meters are larger measurements, millimeters are smaller, so it would take more of them to make a few meters. Oh my gosh. These are kind of confusing in a way because, yeah, I guess we don't use the metric system as much here, but yeah. How about this one? Hectoliters. That's one you don't hear very much. Maybe if you're a chemist or something. Hectoliters. And I want to go to deciliters. Oh, okay, whatever. Sounds good. Hectoliters. So I guess the main measurement here, the basic, these are both metric units because there's a prefix. This one has hecto, this one has deci. But the unit, the basic unit of metric measurement here is liters. So that's one of the ones I can add to the list here. Grams, meters, liters. Those are kind of your basic units. And then you could add those prefixes to them, milli, deca, kilo, etc. Okay. Anyway, whatever happens here, I want to cancel out hectoliters. Why are these words so long? So now I think because in the previous 2 examples that we just saw, it goes from either from the basic unit, like in this last one, meters, to some prefix version of that, millimeters. Or the last one, I think we started with, grams, and we went to kilograms. This one's a little more complicated because we're going from one prefix to another, hecto to deci. I think it would help to go from hectoliters just to liters, because that's basically the conversion we have up here. Where's hecto? Let's see, hecto, oh, right here. There's 100 liters in a hectoliter. And I'm looking at this number, 100 liters in a hectoliter. 100 liters is 1 hectoliter. Because apparently hectoliters are larger than liters. Okay, so which one do I put in the numerator and which one do I put in the denominator? Well, I said I want hectoliters in the denominator, so I must put the 1 there and the 100 liters in the numerator. All right, looks good, but this is like my stepping stone. I'd be ending with liters, but I want to end with something with deciliters. So there must be one more conversion I want. Liters. I'm going to convert with, or use the conversion. Hopefully there's one, right? That goes from, there is. Deciliters to regular, or liters to regular deciliters. How many liters are in how many deciliters? I'm going to go back to that table. 1 liter, because that's the basic measurement unit, is some number of deciliters. Let's see. Oh, geez. Why do I keep doing that? I'm going the wrong way. Oh, my gosh. I just deleted everything, really? Really? Oh, wait. Oh, well. Where am I trying to go now? Deci, right? So it's 1 deciliter is, oh my gosh, no, 10 deciliters. This is 10. is 1 liter. So where was I? I had 2.5, sorry about that, hectoliters. I multiplied by, I want hectoliters down here, and then liters here. And what did we say? Hectoliters, there are 100 liters in a hectoliter, right? 100 liters in 1 hectoliter. But now we want a conversion that goes from liters to deciliters. Okay. And I just saw it, but I forgot what it was. 100 deciliters in 1 liter. That's right. 100 deciliters is 1 liter. And the other one we had was there are 100 liters in 1 hectoliter. All right, sorry. 100 deciliters. I'm matching the units now. Deciliters were in the numerator, liters were in the denominator. Okay. So I think that's it. Was it really 100 for both? I messed that up. It's 10. Oh my gosh. It's 10. I'm losing it. Before everything got erased, I don't know what the heck. I got to think about that. How did that happen? There was 1. It was 10. Yeah. You know why? Because this guy is 10. Why did I write 100 down there? I'm losing my freaking mind. Yeah, and then the 100, maybe just to reiterate where it came from, 100 liters in 1 hectoliter. I went back to that table earlier, and this means 100. Okay. There we go. 100 liters in 1 hectoliter. Okay. Oh my gosh, I'm sorry. I'm losing my freaking mind. All right, now I'll multiply across. I should check though. Are all the correct units going to cancel? Hectoliters, hectoliters, yes. Liters, liters, yes. All I'll end with is deciliters. Is that what I want? Yes. Did I start with the unit here? Yes. I think it's going to be good. I was going to just put DL, but I don't know. There's a few different prefixes that start with D, so I don't know if that's a good idea. Deciliters. Okay, what are we multiplying? 2.5, that's the first number in the numerator, multiplied by 100, that's this number, multiplied by 10, over, and then all the denominators are 1 together, so that's easy. All right, multiplied by 100, multiplied by 10, that just moves that decimal over from 2.5 3 times. 1, 2, 3. Deciliters. All right. Phew. Those are crazy. How many more of these do we have? I'm sorry, this video is getting long, huh? It's just like, this is a kind of a complicated topic, and they just want us to do it in one section, so it's kind of a lot. All right, but I think now hopefully at this point we're getting the hang of it. I know it was kind of throwing a wrench in the gears when we made the problems above that were brand new conversions. Here's a bunch of table full of so many conversions. But it's still the same idea. I know, okay, here I'm converting 175 kilograms to pounds. So I'm going to do the same thing that we said before. At the very beginning, we said, take the number you're starting with and the unit and put it over 1. And then think about the unit fraction you have to multiply by. I want to make sure I see that same unit in the denominator. So I have to go look at one of the tables, look for kilograms. I hope I see one that's going from kilograms to pounds. But if not, maybe there's an intermediate unit I'll go through. Okay, let me go back to the table. I think it was one of these. And notice that this problem is the first since we saw those extra tables of unit conversions that has, finally, this is a US unit. We've seen the last 3 examples were all just metric units to metric units, but now we're involving US units or imperial units. I think that's the right word. I feel like different textbooks call it different things. Maybe when you're in the United States, you call it this. Maybe somewhere else they call it that. I don't know. Whatever, some kind of units. Yeah, so it's not going to be that same table we've been looking at. This guy, because this is only from metric to metric. I don't really need that now, maybe for another problem. But let's see, the weight. The kilograms are in weight, so that's what I want. Here, I see kilograms here. Ooh, and look at that, pounds. Ooh, they're in the same. So even though, notice that this first line, there are 3 units, anything you don't need, you can ignore. They're saying, so now if you wanted to go from kilograms to grams, it looks like this. And then also kilograms to pounds, it looks like this. So they just put kind of 2 conversions in one line, but feel free to kind of pick and choose what you want as long as it's in the same line. But there's 1 kilogram for every 2.205 pounds. Okay, let me see here. See if I can remember that. 2.205. 1 kilogram is 2.205 pounds. And please tell me why. Why is pounds LB? There's neither an L nor a B in the word pound. I'm sure there's a reason. I sure hope so. Well, LB, what? Anyway, I can't worry about that now. Okay, the conversion. I want kilograms in the denominator, so I better put the 1 for 1 kilogram in the denominator, and I guess that means that 2.205 pounds or lbs will be in the numerator. And that almost feels too easy. We're usually doing more than one fraction at this point, but that's what I wanted to end in. Why is lb pounds? It's still blowing my mind. Anyway, that's what I'm gonna check that I got what I want. Okay, kilograms are gonna cancel. Pounds are gonna be what's left. That's good, all right. It's just the 175 in the first numerator multiplied by 2.205 over 1 times 1 is 1, and that'll be in pounds or lb. All right, let me see if I can multiply those guys. We got 175 multiplied by 2, oh, dang it, 2.205. I got 385.875 pounds or lbs, whatever. That's what my 5-year-old says. Whatever. I don't know if he's like from New York or what. Yeah, that's it. Looks good, I think. And you can kind of, I think, because sometimes you heard these units before in your life, you can kind of tell, does that sound right? Kilograms are much heavier than pounds, so I should be getting a bigger number here. There should be a lot of pounds and not that many kilograms. That sounds about right. I'm getting a bigger number at least. All right. How many more of these are there? Oh my God, I'm sorry, this video is so long. But now we're old hats at it, right? This is like easy peasy for us. I got 25.2 liters, and I want to go to pints. Okay. Let me see if we go back and see if there's liters to pints. This is talking about volume. Imagine you're measuring some liquid or something. So I'm going to go back to the volume table. Liters and pints. Okay. Let's see here. Liters and pints. Where can I go? Liters and pints. Volume. So I see liters here. I'm looking at anywhere else. There are liters here, but I think it's going in the wrong direction. Liters to milliliters, liters to cubic centimeters. Any more liters? There's liters to gallons. Where am I trying to go? I'm trying to go to pints, right? So notice that this line here, it has liters in it, but it's either going to cubic feet, which is not really what I want. I'm not looking for volume as in cubic inches or cubic feet. It's going to gallons, which is bigger. So that's a tough one. How about, I think what I want to do is use liters to quarts, because that's kind of a smaller unit, and then take quarts to pints. I think that's what I want to do. So this, I think, is no good. It's taking me in the wrong direction. It's kind of like I'm trying to cross a river, and there's a rock I can step on, but it's kind of far. It's going in the wrong direction. I don't want to go that way. So I think that's what I need to do. Use 1 quart, that one there, is 0.94631 liters. 0.94631. 0.94631 liters. 0.94631. Can I remember that? 0.94631. 4631. Oh no. Was it? Oh my gosh, I already forgot. Is it that many liters in 1 quart, or that many quarts in 1 liter? Oh my gosh, I'm losing it. That many liters in 1 quart. Oh my lord. In 1 quart. Okay, I'm gonna use that conversion. So the number I started with, 25.2 liters. I want to make that over 1, and I want to make sure that the fraction I multiply by has the same unit in the denominator, so they'll cancel. That means I should put the 0.94631 in the denominator, because I want to see liters in the denominator. That means, I guess, quarts are in the numerator. Quarts. All right, and then this is where I check, especially if I'm half asleep, I write that down and I say, wait, am I done now? Or what was I trying to do? Oh yeah, I'm trying to go to pints. Would that be where I end? No, this is not pints. All right, I guess I probably need at least one more unit fraction. And I think I saw the other conversion that I boxed and said we need to use. There are 2 pints in 1 quart. And I know I need to put it that way, not upside down, not 1 quart on top and 2 pints on the bottom. I know it needs to be this way because I want to see quarts cancel along the diagonal. 2 pints equals 1 quart. All right, I think this is gonna work. I'm gonna multiply across. I got the 20, let me see. Write this down, 20. Feel free to just multiply and write the answer down. You don't have to write this like I'm doing. 25.2 times 1 here, and feel free to skip the 1. He's not gonna contribute. and then times 2 over, now what's in the denominator? 1 multiplied by that terrible fraction, 0.94631, multiplied by this one. And that's all, the only unit left. Everything's canceled except pints, so that's a good sign. Now it's just the math I have to do. Okay, well, the numerator, I think I can do that. 25.2 times 1 times 2 is 50.4. And then the denominator is just that weird decimal 0.94631 multiplied by 1 twice. It's just going to keep that same 0.94631. All right, I think I can handle that. 0.94631, and that's in pints. Now I just need to divide those. That I cannot do in my head. I'm going to have to use a calculator. 50.4 multiplied by, or dang it, not multiplied by, divided by 0.94631, 53.26 or so, depending where you want to round. Again, they didn't tell us where to round. 53.26. And what were we doing? Pints. Pints. Oh my gosh, I can't spell. Whew, that's it. Wow, this is a lot. I'm sorry about this video being so long. But, you know, feel free to skip around because it's so boring, or maybe it'll help. What now? Let's convert miles to meters. Okay. And I know these problems for sure, they were very overwhelming for me as a student. I was very overwhelmed by them. I just like, because you know why? Because it's kind of like word problems. When I get them, here's a word problem. I don't see how to, every step along the way and end the end result. I don't know how to get there, and it freaks me out. But eventually I learned to just let go. You know what? You don't need to be in control of it. Just let it be. See how it goes. I don't really know what I'm doing here, to be honest with you. But you know what? I've learned it's okay. Just try something. Let's see what happens. I'm starting here. So at least write something down, see how it goes. 8 miles. All right, cool. I don't know where I'm trying to go. How I'm going to get there? No, I know where I'm trying to go. I want to have meters in the end. Maybe there's only one fraction or one unit conversion that gets me from miles to meters. Maybe there's more than one. But this is a tough one because it's US units. You know, the miles is in the US units or imperial units or whatever. And then meters are in metric units. Those are always the tough ones, I think, if they're mixed, you know. Okay, miles and meters. Let me go back and see what we got. It's going to be distance or whatever. Where was that table of... There we go. Length. It's not weight or mass, huh? It's talking about... and you know what? How is this possible? I already forgot what the units were. I need more coffee or something. Miles and meters, that's right. Come on. Don't get old, you guys, I swear. Don't get old. Miles and meters. Okay, what do I see in this table? What do we got? I'm starting with miles, right? So remember we mentioned, you know, I want to see the units I'm starting with. That's more important. So I'm starting with miles. I see miles here. Are there miles and any other? That's the only one. Oh, no, right here. So I think either of these could work because notice this one is taking you either from miles to kilometers or vice versa. This one's going from kilometers to miles. So either one of these would work. Actually, this is kind of a weird one. Let's see. I'm going to write it. Because these as unit fractions, I could say this top one that I boxed is 1 mile. And it's 1.6093, what is it, kilometers. But if you take those two numbers, the numerator is 1, the denominator is 1.6093. If you divide those, 1 divided by 1.6093, you would get this number here, 0.6 da-da-da-da-da. So another way you could write it is 0.6, what is it, 21371, 21371 kilometers for 1 mile. So this unit fraction and this unit fraction are pretty much the same. It's just, are you doing like the first one? Are you wanting to do 1 divided by 1.6093, or you want to take 0.621371? No, that doesn't make sense. Yeah, or divided by 1. Anyway, 1 divided. That's what I'm trying to say here. All this is just to say that 1 divided by 1.6093 is 0.621371. So these two that I've boxed here, they're the same. Either one would work. There might be one that might be more convenient, I guess, or the math will be easier, but either one will work. I don't know. I kind of like the top one. I don't know why. 1.6093 seems a nicer number, but either one should work. So I'm going to write 1 mile is, what is it? 1.6093 kilometers. Oh, let's see if I can make it back to where we were. So much. 1 mile is 1.6093 kilometers. And I know that's not where I want to end. I want to end in meters, but once I'm at kilometers, now I've converted from the US unit to the metric unit. That might be easier. So which one of these, mile or kilometer, do I want to put on the denominator? Well, I want miles to cancel, so I better put mile or miles on the bottom. That means the 1 that goes with the miles needs to go on the bottom, and then the 1.6093 kilometers will go on the top. And we're almost there. I want meters, not kilometers, but that's pretty easy. I can go back to that simple table, the metric table, and I'll find some kind of conversion that goes from kilometers, because I want to make sure kilometers are in the denominator, so they cancel on the diagonal, and meters are in the numerator. So there's probably some conversion. You probably memorized it maybe, from kilometers to meters. Okay, so go back to that metric table. Where were we? Let's see. Kilometers to meters. You don't need to look for meters in this, because meters is the basic metric unit. I just want to look for kilo. It's there, the second one. I know I crossed this table off, but that was only for that one problem we were doing. Now I do want this. They're a kilometer. 10 to the third power. So there's 10 to the third power, which is 1 followed by 3 0. I guess we're talking about meters in 1 kilometer. But it could be liters. 1,000 liters in a kiloliter. So I guess that's the measurement I want, or the unit conversion. 1,000 meters in a kilometer. 1,000. Don't forget. So much easier to remember, right? 1 kilometer is 1,000 meters, rather than these random numbers with the US units. Okay, so what did we say? Does the 1 go in the numerator, or the 1,000? Well, I wanted kilometers on the bottom, so I must want to put 1 down there and 1,000 up here, I guess. Yeah. Okay, so it looks like I'm ending with 8 multiplied by, because we got the 8 here. Where is it? 8 multiplied by 1.6093 multiplied by 1,000. Okay. Feel free to just multiply them. You don't have to write this out. But I just want to kind of show the math we're doing. Setting it up with all those fractions is really just to make sure this whole thing is making sure the units are right. This is kind of confirming, am I supposed to be multiplying or dividing by something? This is kind of how you're proving it to yourself. The units are canceling, so I know I'm multiplying or dividing correctly as long as the units cancel. But I'd be ending in meters. So, okay, let's see. What are those numbers multiplied together? 8 multiplied by 1.6093, and then multiply that by 1,000. And I get, hopefully I did this right, 12,874.4 meters. Oh, that's a lot of work. Phew. We did it. This is our last one? Oh, thank God. I know you guys are thinking that. I mean, you could turn the video off if you wanted to. You don't have to listen to me. Okay. Now I want to convert tons to kilograms. All right, it looks like weight and mass and all that. Tons is a US unit, right? We're talking about like an elephant is 2 tons or whatever. But kilograms or grams is a metric unit. So those, to me, I think those are always the hardest when you're going from metric to US or vice versa. But anyway, we know it. We know what the drill by now. I just say, what am I starting with? Okay, this number of, I guess the unit is tons, and I want to get to kilograms. I'm going to go look. I definitely want to see some number of tons converted to something. I hope kilograms. If it's not kilograms, okay, that's fine. But, you know, we'll see what we can do. I definitely want to see tons in there, though. Okay, mass and weight, that's where tons would be. I think, if I'm looking at this right, I think the only tons are here, 1,000 pounds. Wait, is that right? Unless, yeah, I think so. Did I say 1,000 pounds? 2,000 pounds. Ay. 1 ton is 2,000 pounds, so I think I'm going to bring that down. I'll definitely use that. But now I'm thinking about it, we want kilograms, and I think our stepping stone here is pounds. I'm starting with tons, and I want to go to kilograms, but I'm using pounds as my stepping stone. If I'm standing on the stepping stone of pounds, I want to step off that and eventually get to kilograms, which I see up here. So I think we're going to need both of these conversions. I'm going to bring them down and write them down below where our problem is there. Okay. That way I don't have to keep moving the screen and hurting everyone's eyes. Sorry about that. There we are. This is where we started, right? Yeah. Okay. What did we say? How many tons? 1 ton is 2,000 pounds. And I know I don't want pounds, but you know what? It's a means to an end. I don't want pounds, but it's going to help me get to where I want to go. And then they said there was 1 kilogram in 2.205 pounds. So I think I need to use both of those. First, though, I want to use, like we said, even if you know you need to use more than one conversion, I definitely want to make sure I get rid of the unit I'm starting with, tons. Why does that look like it's spelled weird? So which one of these had tons? I want to put that in the denominator. 1 ton, and then there were 2,000 pounds. Okay, I'm going to put that in the numerator. All right, but again, I don't want to end in pounds, so I need another conversion or a unit. I already used this, so I'm going to kind of try to cross it off and get it out of my mind. Now I'm going to use this one somehow. And which way is it going to be? Is it going to be 1 kilogram over 2.205 pounds or 2.205 on the top? Well, the way to figure it out is what I definitely want to see is I want to step off the stepping stone of pounds. I don't want to be in pounds anymore. So I want to make sure I see pounds in the denominator when I do the next unit fraction, pounds. All right, which number was next to pounds? 2.205. So he's got to go down here with his friend, the right unit. The numerator is going to have kilograms, 1 kilogram. This is probably one of the more complicated ones because in the end we're multiplying and we're dividing here. Wow. I think we're okay. This is where I need to check. All that was a lot. Tons cancel. Good. And we started with tons. That's a good sign. Pounds cancel. Yes. And what are we left with? Is that the right unit we wanted? Yeah. Whew. For me, I feel like this is where I feel home free. That was the hard part, setting it up, just kind of knowing which unit conversions to use and which kind of unit fraction, which way should it be oriented, you know? Should it be this way or should it be upside down? Which one should be in the numerator? Now it's easy. I just multiply across 5.3 multiplied by 2,000 multiplied by 1. Easy peasy. In the denominator, I have 1 multiplied by 1 multiplied by 2.205. And it'll all be in kilograms when all's said and done. Whew. So I'm going to go multiply, okay, 5.3 multiplied by 2,000. So in the numerator, that's 10,600, I believe, yeah. And then the denominator, 1 times 1 times 2.205, that's just 2.205. Oh, what the heck? Why'd I put another decimal? 1 decimal is enough. Now I need to divide those guys. 10,600 divided by 2.205. Okay, what is that? That's about 4,807.26 or so. And we're in kilograms. Whew, that's a lot of work. I know this was a long video. I hope you feel okay and you hung in there. Or if you skipped around, I totally don't blame you. I'm sorry if I blathered on a lot, but we're going to do some kind of real life applications of this in the next section, which don't be too scared. It's like kind of like word problems, but it'll say, oh, Josie, I don't know. She has this many tons of concrete. I don't know. I'm just making this up on the spot. But the measurement that they use at work is in kilograms. So how many tons does she really have or whatever? But really, you can kind of basically just say, well, she's just trying to convert tons to kilograms. So yeah, so don't get too scared, but we'll do more of this and it'll probably get easier the more we do. So thanks for hanging in there. That's a long video. God bless you if you're still here.